Welcome to a question where they give us a y function and they want us to take the derivative. I hope you know this is the same as y prime, just another way of saying same thing. So we have this function y equals the square root of x squared plus 3. Okay, and then they want us to take the derivative. Well, I would first rewrite y equals, and I would make that x squared plus 3 to the half power. You aware of that? Anytime you have the square root of something, that's the same thing as that inside to the half power. And so that's a much easier way for us to do derivatives is to get powers with numbers. So that's a power, it's not times a half, it's to the half power. So a square root is the same thing as a half power. So I would rewrite. So I haven't done the derivative yet. I just did a rewrite. Now let me do the derivative. So I rewrote it to make it easier to take the derivative. So how do we do the derivative? Well, this is chain rule. Chain rule. Remember chain rule? The chain rule, whenever you have, because this is the inside function, right? And this is the outside function. Remember how you do chain rule? Put it over here real quick. Whenever you have one function inside of another, you got to do chain rule. It says if you have an outer and an inner, outer, doesn't matter left or right, just think outside inside. It can be in the right, left, whatever, it's going to be outer. See how this is on the right, but it's really the outside layer. So whether it's on the left or it's on the right, whatever, it's the outside layer. And the derivative of it is you do the derivative of the outside layer, keep the inside unchanged times the derivative of the inside layer. So that's what I'm going to do. I'm going to take that half, I'm doing the outside layer right now, bring it down, right? We always bring down numbers. There, keep the inside the same for now. That's just the inner layer. And what do you do with here? You subtract, let me do it in red, subtract 1 from the power, so that'll become minus a half. So I just did the outer layer times now the derivative of the inside layer. So this will be derivative of the inside layer. What's the derivative of x squared plus 3? It's just 2x, right? Because you bring down the 2, subtract 1 from the power, it's just 2x to the first. And then the 3, that just goes to 0. Whenever you have a number with no x next to it, the derivative is 0. So there we go. And you literally could just type that in and it'll take it. That's totally a fine answer. Now, you might have that version or you might have this other one. Let me show you. This is another version you might have. You might have like a tangent or cotan or something like that. Let me do this one real quick. So there's that one, and then there's this one. So in this case, I have y equals cotan x squared plus 2. So this is the outer layer. And this here is the inner layer. So you could have that one. You could have like a square root kind of function, or you might have something like this. So then if you're going to do the derivative here, you got to do the outer first, right? So chain rule says, what now what's the root of cotan? Yeah, let me write out a few of these, see if you know these. So the derivative of secant is secant tangent. Derivative of tangent is secant squared, because you might have something different than I'm looking at right here. And the derivative of then the cos, like cosecant, it's going to be negative because all the derivative cofunctions are negative. Then it's just the co of secant, so it's co of those guys, cosecant, cotangent, cosecant, cotangent, but it's always negative. Or if you have cotangent, again, the derivative of cofunctions is always negative. This would be co of tangent, so it would be co of this, cosecant squared. All right, so we have cotan, derivative of cotan right here, negative cosecant squared. So negative cosecant squared. Now keep the inside function the same at first, right? That's the inside function. times, and chain rule says now, come over here and take the derivative of the inside. What's the derivative of that inside function? It's just going to be 2x. Because again, the 2 just comes down, lower the power by 1, and the plain old 2 without an x just goes to 0. So there it is. That's a valid answer. That's what they have right there. Just like that. Oh yeah, how do you write that 2 power? Let me help with that. So the way we would write that. I'd probably put this negative and this 2x in the front. You don't have to, but it's kind of nice. And then we're gonna have, or here, I'll just keep the color scheme the same. You don't have to put that 2x in the front. And then we have cosecant x squared plus 2. And then you put around that whole thing, the 2 power. See, because that 2 power is on the cosecant. That means it's on the whole cosecant function. The x squared plus 2 is plugged into the cosecant function with the 2 power outside of the whole thing. So there's the right answer. So you could have different, this question does versions like that with square roots or tangent, cotan, sine, cosine functions. Either one of those. There we go.